In this video we're going to talk about pulleys, and as we talked about in class, a pulley is a device that's used to change the direction of tension, or it's used to reduce the force required to lift an object. And we're going to go through a lot of pulley problems coming up in the class, and so I wanted to go through a couple of examples in how to solve the math part of pulleys, because it's a little bit different than what we've seen before. So let's look at this first question. It says the pulley system shown below is known as an Atwood machine. And a machine is anything that makes a job easier. And we talked about Atwood machines in class and how they make it easier to lift objects because they're counterbalancing on one side the weight. Anyway, we're supposed to find the acceleration of the system and the tension in the rope of this pulley system. And the first thing that I always like to do with these pulley type of questions is to look at it and then just intuitively think, which way is the pulley system going to move? And is there going to be any motion at all? And it's not the case in this problem, but if they were the same, if these two blocks had the same mass, say they were both 25 kilograms, then it would be easy to say, well, it's not going to move. There's not going to be a net force, and according to Newton's first law, if there's no net force, the forces are balanced, and so it won't accelerate. But in this case, one of the blocks is 27 kilograms and the other one's 25. And so the first thing to always do is to draw which way this pulley system is going to move. And we know it's going to move to the left because the left block it has more mass. And so I'm going to write acceleration is positive. And again, if we go back to Newton's second law, if there is a net force, then there will be some acceleration as well. And so it's going to accelerate up on the right and down on the left. And the tricky part about these pulley questions is maybe keeping track of your sign notation. On the left side, on the right side, sorry, we said that up was positive. So I'm going to make a little note of that. So on the right side, up is positive. On the left side, see this arrow is going around and down, and we said that was positive. So everything on the left side that's down is positive. And so we're going to keep that in mind as we go through and solve this problem. But now we can go through and fill in our free body diagram. So we have the force of gravity, which is equal to mg. And so 25 times 9.8, 25 times 9.8 is equal to 245 newtons. And we know that there's a force going up in this rope, and that's called tension, so I'm going to put tension right there. Now let's do the same thing for the left side of this system. We know that there's the force of gravity pointing down, and that's again equal to mass times acceleration due to gravity. So 27 times 9.8, and that's 264.6 newtons. And so again, just to reemphasize why it's going down on the left, the force of gravity is greater on this left side than it was on the right side. So this side's going to move down while it's pulling everything on the right side up. Okay, and then we forgot tension on this side, so we have the force going up here, which is our tension force in that rope. Okay, and maybe you ought to mention that there's no forces going left and right with either one of these free body diagrams. So the only forces that exist are going up and down. Okay, and so now here's where the math gets a little bit different. The question wanted us to find acceleration and tension. So we don't know tension and we don't have acceleration yet. But there's a little trick that we can use in solving these pulley questions, and that's to follow Newton's second law. So remember Newton's second law, it said if force net is equal to the mass of the object times its acceleration, F equals ma. And so that's what we're going to do, except we're going to break this system into two parts. Everything on the right, and then everything on the left. I'm going to take everything on the right and make an equation out of this following Newton's second law. And I'm just going to name it equation number 1 because we're going to have the other side as well. So in equation number 1, the force net, if we look at it, now tension is going up, and I said everything on the right was positive. So I'm going to write a positive tension. And now, if we're going to take the net force here, we have to subtract off everything that's negative. So we're going to minus the negative force, which was, in this case, gravity, 245 newtons. And that will give me a net force, and that's going to be equal to the object's mass, which on the right side was 25, times the acceleration of the object. And we don't know the acceleration of the object. And so if we look at this equation we just created, we have two equations. We don't know tension and we don't know acceleration. And there's no way to find any answers because there's two unknowns for one equation. So there's the trick that we can do, and that's by taking the other side and creating an equation just like it, like the equation number 1. And so we're going to create another equation, and I'm going to call it equation number 2 for the left side. And so everything on the left side, we said if it was down, it was positive. So that 264.6 newtons of gravity is going to be positive. So 264.6 is positive. And now we're going to subtract off tension. So minus tension for the net force on this side. And that's going to be equal to the object's mass, which is 27, times its acceleration. And now we have two equations with two unknowns. And the thing that we try to do there is to cancel out one of our unknowns. And so if we take equation number 1 and add it to equation number 2, you're going to see, and you're going to notice, one of your unknowns is going to cancel out. So tension here on the first equation is positive. If we take tension minus tension, they will cancel out. So we can cancel out the tension values. So now we're going to finish adding together these two equations. So 264.6 minus 245. So we do that on my calculator. 264.6 minus 245. And that's going to be equal to 19.6. Okay, and then let's add everything on the right side together. So 25A and 27A, if you add them together, that's 52 times A. And now we have one equation, one unknown. If you ever get to this point and your tensions don't cancel out, you've made a mistake somewhere. So go back and see your sign notations and see if you can get them to cancel out. So now we have one equation, one unknown. To solve for acceleration, we divide each side of this equation by 52. So 19.6 divided by 52. And we get our acceleration is equal to 0. If we round to 2 decimal places here, 38. So 0.38. And acceleration is always measured in meters per second squared. Meters per second squared. Okay, so there's our acceleration of the system, and what that means is this block on the right is going to accelerate upwards at 0.38 meters per second squared, and the block on the left is going to accelerate downwards at 0.38 meters per second squared. But if we remember, the question also wanted us to find tension in the rope, and so now you can take this acceleration value that we just found and plug it in either one of these equations for A. I'm going to plug it into this top one. Again, it doesn't matter. It will give you the same value. And so I'm going to do that right up here. So I'm going to rewrite this first equation. So tension minus 245 is equal to 25 times A, which we found was 0.38. And so take 25 and times it by 0.38. I get 9.5. So 9.5, and that's going to be equal to tension minus 245. So to solve for tension, you'd add 245 to each side, so plus 245, and I'm getting tension in the rope is equal to 254.5. And tension is always measured, it's a force, so it's measured in newtons. And so there is your answer. Let's go through one more example, a little bit quicker this time, just to give you another chance to see it. On this time, we see that it wants us to find the acceleration of the system and the tension in the rope again. And so real quickly, by inspection, you can see that this system is going to move to the right. So acceleration is positive this way. So on this side, up is positive, and on the right side, down is positive. And again, it's accelerating that way. We have to keep track of our sign notation. So let's figure out all the forces here. Force of gravity, which is equal to mg, will be 22 times 9.8, and that's 215.6. And we know that the force going up in this rope is tension, and that's all the forces on this block. So let's move to the left. We know that there's going to be a force of gravity on this block, and 15 times 9.8 is equal to 147 newtons. And so again, this force is greater, so that's why on this side it's coming down, and on the left side it's going to be moving the system up. Okay, and then we also have tension on the left side as well. So let's create our equations that follow Newton's second law. Force net is equal to ma. And for our first equation, it doesn't matter which side you choose. For equation 1, it's just arbitrary. Let's choose the left side this time. Tension is positive, so tension minus the force of gravity, which is 147, is equal to the mass of the object, which is 15, times its acceleration. Okay, and let's create an equation for this side now. We said down was positive, so this force of gravity, which is 215.6, is going to be positive, minus everything that's going up, which is tension, and that's going to be equal to 22 times acceleration. Okay, and we're going to add those two equations together. And you should notice that our tension, we have a positive tension on top and a minus tension here, will cancel out. So we got positive 215.6 minus 147, so 215.6 minus 147, and that's going to be equal to 68.6. And that's going to be equal, and remember we're adding these two equations together, so 15 plus 22, and that is 37 times a. Okay, now to solve for a, you divide each side of that equation by 37, so 68.6 divided by 37, and I get 1.85, so acceleration is equal to 1.85 meters per second squared. Okay, and now once you find your acceleration, it doesn't matter which equation, but plug it back into one of them for your acceleration value. And so we do that real quickly. We have the top equation, tension minus 147 is equal to 15 times a. Whoops, I forgot to plug it back in. So a is 1.85. So 15 times 1.85 is equal to 27.75. And that's going to be equal to tension minus 147. To find tension, you would add 147 to each side. And I'm getting that tension in that rope is equal to 174.8 newtons. All right, and that's it. That's how you solve these pulley problems in terms of their mathematics. What I've got for you is a video physics assignment that's very similar to these two problems. There's going to be two questions that will follow. Again, they're very similar, so if you get confused, go back in the video and rewatch and try to see where maybe the mistakes are being made. But again, if you still can't figure it out, you're welcome to stop by anytime and we'll figure it out together. So good luck. I'll scroll through them slowly so you get a chance to write them down. Good luck.